This is GMAETS 41. You are welcome to this channel. Excellence. Forget about what you have here on the board, please. This class is not focused on maths, no. But I decided not to wipe these, at least for you to see it before we solve this supposedly physics question and or further maths related question. But then I want to remind you of this, that we had just had this class today, and hence the importance of this special angle that I had taken my time to teach you, friends. I'm going to wipe this now, and then I will dictate this question that we are about to solve and draw the diagram, okay? In fact, you can listen to the question. The figure below shows forces 3 Newton, 10 Newton, 3 root 3 Newton, and 6 Newton acting on a particle P. The resultant of the 4 forces is, so I'm going to draw the diagram here on the board. Like I said, this is one of the many reasons why a student should not joke with understanding, the foundation of several topics, the secrets of several topics in different subjects, because they apply this knowledge when you are exposed to problems. Just imagine, from the concept of special angle, we are going to deal with this physics problem. Physics. All right? We're going to code it Physics 101. Now, this problem is both equilibrium related problem when you're talking about non-parallel coplanar forces. It is further mass related problem. It is scalars and vectors related problem. That's vector resolution problem. I will sketch the diagram on the board. So this is what we have. This is the diagram, something like this. Something like this. So the mass, we have a mass here. Now the mass is acted upon by system of forces. Here we have 3 root 3 Newton. Then we have this force acting this way at this angle of 30 degrees. This is 10 Newton. We have a force here, 3 Newton. This particle is called P. Then we have a force this way. This force acts at, this is a force of 6 Newton, and it acts at 60 degrees from the negative x-axis. And this is pretty cool. This is the diagram. This is the diagram. And then we have the figure below. So the question was asked, the statement was made before the figure. The figure below shows 3 forces. Shows forces 3 Newton, 10. Anyway, let me just copy the question anyway. I'm going to use the word the figure. The figure above shows forces 3 Newton, 10 Newton, 3 root 3 Newton, and 6 Newton. Acting on a particle. Acting on a particle. The particle is called P. The resultant of the 4 forces is, so we don't know, we have the options provided. A, 10 root 3 Newton. Option B, 10 Newton. We have option C, 5 root 3 Newton. Option D, 5 Newton. This question is extracted from an exam body, JAM. At least I'm aware that UNIZIK, Nnamdi Azikiwe University, has also asked this question as well too. Now, how do we solve this problem? I think at this point I want to say welcome to this class. Let me check the network situation before we solve this problem as fast can be. This is not a class to come and explain all the in and out of this. No, I just want to solve it. But then to remind you of the importance of what I just taught you, we concluded that class on special angle, the foundation, the basis, okay? And then how you apply that knowledge of special angle. Permit me to check the network situation, please. All right. Chinedu, how are you? You're welcome to join the class once again, as always. So this is the diagram we have. This diagram, we have a particle, and the particle is acted upon by several forces, 4 of them. These forces are called non-parallel, but coplanar because they act on a plane. Are you following? They are non-parallel coplanar forces. You encounter a problem like this under equilibrium. You also encounter it under vectors. We are asked to find the resultant vector. How do we get the resultant of? We are asked to find the resultant of the 4 forces rather. How do we get the resultant of, anything? Yeah. Simply put, you use Pythagoras theorem. I'm going to say that the resultant of this force is equal to, permit me to use F as the resultant force, maybe F subscript R. I'll give you the formula directly. Now, since these forces are acting on a plane, they are acting on a plane and they are non-parallel, you are meant to resolve all these forces into 2 perpendicular directions. You're going to resolve the 4 forces vertically to get force in the vertical direction Fy, F sub y. You are also going to resolve the 4 forces horizontally so as to get Fx, force acting along the x-axis. Now, of course, once you get the vertical force, the horizontal force, you now have 2 perpendicular forces, meaning they meet at 90 degrees. So you are going to use Pythagoras theorem to obtain the resultant. So we're going to have Fy, Fx, and then the resultant, I'm using F subscript R for it. We all know Pythagoras theorem at this point, So this is going to be square root Fx squared plus Fy squared. This is the formula you need to use to solve this problem. So to get our resultant now, we need to know all the forces acting along the x-axis. We need to know all the forces acting along the y-axis. And this is where the knowledge of vector resolution comes in. And whenever you are dealing with vector resolution, you make use of angles. Because there we make use of sine theta and cos theta. By standard, for problems like this, if you are resolving horizontally to get your Fx, let us get some Fx. That is addition of all the forces acting along the horizontal. You are going to make use of the formula F cos theta. You're going to use F cos theta. You're going to use F cos theta. That is each of the forces multiplied by the angle that the force makes with the x-axis, with the horizontal axis. Then if you are resolving along the vertical axis, that is along the y-axis, you're going to use F sin theta. So you want to take note of these formulas, okay? To resolve along Fx, you use this. Along Fy, you use this. I hope this stuff I wrote there is showing. Let me check. Good. It is showing. So let us resolve this. We're going to take all the forces along the horizontal axis. I will start with these 3. And remember, we're using F cos theta. The F value here, the force value here is 3. So it's going to be 3 times the angle that this force, this horizontal line makes with the horizontal axis. Of course, this is the line we are talking about. The angle it makes with itself is 0 degree. So we are evaluating F cos 0. And if you evaluate f cos 0 from special angle cos 0 is equal to 1, our f here is 3. So it's going to be 3 times cos 0. And cos 0 is 1. 1 times 3 will give you 3. We have gotten the value of the force, one of the force along the horizontal. I'm going to add it to the value of this force, 10 Newton, resolved along the horizontal. So it's going to be 10 Newton, look at it, F cos theta. 10 Newton times cos of the angle it makes with the horizontal axis, which is going to be 10 cos 30. And what is the value of cos 30? Cos 30 is root 3 over 2. Cos 30 is root 3 over 2, which means we are going to do 10 times square root of 3 over 2. Do not forget this force, if you resolve it along the horizontal, is going to be 10 cos 30. 10 cos what? 30. And cos 30 is square root of 3 over 2, like I said. Now, let us work it out with our brain. 10 times square root of 3 over 2. The over 2 will divide 10 to give you 5. So we are having something like 5 root 3. This is the value of this force along the horizontal axis. We are going to proceed again. Come to this. What is the horizontal force component or value of this force? 3 root 3. And it is 0. You know why? If you are solving this, it's going to be 3 root 3 cos of the angle that this force line makes with the horizontal axis. And of course, this force line, 3 root 3, makes an angle of 90 degrees with the horizontal. And you know that if you evaluate 3 root 3 cos 90 is already 0 because cos does not exist on the vertical axis. It means that this part is going to produce 0 for us. 3 root 3 times cos 90. Cos 90 is 0 times 3 root 3 will give you 0. No need of fixing it, but I just fixed it for you to see. We move on now to evaluate the value of the force along the horizontal axis, which 6 Newton contributes to the total force along the horizontal axis. So what do we do? Once again, we come here. We're going to evaluate 6 cos of this angle, which is cos 60, right? Either you use 6 cos 60, or you can decide to, from this horizontal axis, you measure down to this 60. From this horizontal axis to this horizontal axis, the angle is 180 degrees. If you add it to this 60, you're going to get 240 degrees. So the angle that this 6 Newton force line makes with positive x-axis is 240 degrees, which means you can be evaluating 6 cos 60. Oh no, 6 cos 240 rather. 6 times cos 240. And do not forget, based on the special angle concept I taught you, 240 is equivalent to which angle in the first quadrant? 240 is equivalent to 60. Because it's going to be 240 minus 180. Remember that? So simply put, what we are saying is you could just evaluate 6 cos 60. But remember to ask yourself, in this quadrant, what is the value of cos in this quadrant? This is the third quadrant. And in the third quadrant, cos is negative. Even sine is also negative there. It is only tan that is positive in this third quadrant. So if you are evaluating 6 cos 60 in this quadrant, remember that it is going to be minus. So this is going to be plus open bracket 6 times cos 60. Cos 60 is 1 over 2. 1 over 2. So if you're doing 6 times cos 60, that's the same as 6 times 1 over 2. These are special angles. So come on, you don't stress yourself about it. Just make sure you take the lessons on special angles I taught already, and all these things, they are 1 plus 1. It's just because I need to just explain a little thing. Let it not be that I came to just solve question and leave. You know, I don't do that much on this channel because this channel is dedicated to teach students. It's not to come and do some sort of videos and leave. No. Otherwise, I would have solved this since without any stress. So this part is going to be minus 3. Remember, cos is negative in the third quadrant, bringing this minus. Then you now evaluate 6 times cos 60. And cos 60 is 1 over 2. Multiplied by that 6, you're going to get 3. So the final thing is minus 3. Now, looking at this, if you simplify this, you're going to get 3 plus 5 root 3 plus 0 plus minus 3. Plus minus 3 is going to give us minus 3. 3 minus 3 is 0. It will go off. This 0 will also go off. You are simply left with 5 root 3 Newton. This is the total force acting along the horizontal axis by these 4 forces. So if you resolve all these 4 forces along the horizontal, the total force along the horizontal is 5 root 3 Newton. Quite simple. The reason I'm solving this particular question is just to apply the knowledge of special angle, how you work it very fast even without calculator. So you appreciate the last life classes we had. Let's move on and obtain our sum Fy. We are going to repeat the same thing exactly. The only thing we now have to do is to make use of sine instead of what? Cos. So I'll come over here. It's going to be F sine theta, which is this force times sine of the angle that this first line makes with the horizontal. This is already horizontal. So the angle it makes with itself is 0 degrees. So it's going to be 3 sine 0. And sine 0 is already 0. 0 times 3 will give you the 0. 3 sine 0 is 0. 3 times 0 is 0. Remember that under our special angle class, I stated clearly that sine does not exist along the horizontal, just like cos doesn't exist along the vertical. So the first force contributed by these 3 Newton along the vertical y-axis, right, is 0. This thing is purely horizontal, so there is no way vertical will appear there. Let's move on to the next. This is going to be plus. Come to this 10 and evaluate 10 sine 30, because the angle that this force makes with the horizontal is 30. 10 sine 30. Sine 30 is 1 over 2. 10 times 1 over 2 is going to give you 5, because the 2 will divide 10 to give you 5. You see, I'm playing with it. Before somebody will pick calculator and press, I'm done with whatever I want to do. So take note of this, please. Remember that our special class on special angles, make sure you take them as a science student. In maths, like I say, you meet application of that. In physics, you also meet. This problem is specifically physics related. Please let us move on to the next force, which is that of 3 root 3 Newton. Remember that this force is acting at 90 degrees. So it's going to be 3 root 3 sine 90. Sine 90 is 1. 1 times 3 root 3 is going to give us 3 root 3. Then finally, we come to this. In the third quadrant, sine is negative. So without wasting time, I'm going to fix negative, and then I will evaluate F sine theta, which is 6 Newton force sine 60, the angle it made with that horizontal axis. Okay, 60 degrees, just like you're seeing it here. If I were to measure the angle from the horizontal this way down to this 60, it's going to be 240. That is from the positive x-axis, measure up to this line of the force of 6 Newton. I'm going to get 240, because from here to here is 180. Add it to 60, you get 240. In that case, if I'm evaluating 6 sine 240, sine 240 will still give you the same result as sine 60. The only difference is that sine 240 will give you a negative value, which is why you have this minus there. But if you are using this 60 directly, you want to remember that since this angle is directly in the third quadrant only, you didn't measure it from this positive x-axis anti-clockwise this way down to this point. You're only interested in this 60 degrees in the third quadrant. On your own, while you're evaluating 6 sine 60, remember that sine in this quadrant is minus. Like I said, if you're using the 240, which is the angle measured from positive x-axis anti-clockwise down to this line, you don't need to put this minus. All you have to do is use plus. If you evaluate sine 240, the minus will appear automatically. Anyway, let us move on, please. 6 times sine 60. Sine 60 is root 3 over 2. So if you're evaluating 6 times sine 60, it's going to be 6 times root 3 over 2. The 6 will be reduced by the over 2. You get 3 root 3. So I have this 3 root 3. Let us simplify, please. This is 0 plus 5, which is still going to give you 5, plus 3 root 3 minus 3 root 3. This 3 root 3 minus 3 root 3 is going to be 0, and so you are left with just 5 Newton. This is good. We are done. It's just for us to now get the resultant. You love this? Remember the focus of this class. It's not even all about solving this question with respect to what the examiner said we should get. The reason I picked this question to solve is simply to show you an application of having excellent knowledge of how to evaluate special angles. You get your answers without calculators and you get them very fast. You can do this. You can do it. Please let us move on. From here, we can now obtain the resultant force, which is square root of, remember, fx squared plus fy squared. I'm going to work this straight on without wasting time. Our fx, look at it. So you have to come and square this 10. If you square this 10, what would you get? You know, when you are squaring 5 times root 3, it's going to be 5 times root 3 raised to power 2. Apply your power law of indices. 5 times root 3, all raised to power 2, the power 2 will distribute to each of them. So it's going to be 5 squared, which is 25, times root 3 squared. If you have square root of 3 and you square it, that square will cancel that square root. So the 3 will be left. This is simply 25 times 3. In fact, let me write it out here. 25 times 3. I could have just evaluated it as 75 straight on without wasting time. But it doesn't matter. Let's still go. The next is Fy. You square it. There is the total force along the y-axis is 5. If you square 5, you are going to get 25. If you work on this, what would you get? 25 times 3 will give you 75. 75 plus 25 will give you 100. Square root of 100 is 10. So, the resultant force acting on this particle is 10 Newton. All these 4 forces you're seeing here pulling this object. The total force, resultant force acting on that particle is 10 Newton. You love this, right? We are done with the class. This is just what I want to deliver this evening, like I told you, friends, by 9 o'clock. But before I finally close the class for today, I'd like to give you work to do because I'd like you to go a bit further. Assuming I give you the mass, assuming I give you the mass of this particle, assuming I give you the mass of the particle, let me indicate it here. We are assuming, let me check that that part is showing. Good. So, assuming that mass of P is, let's say, 0.5 kilogram. Let us assume that the mass of this particle being acted upon by these 4 forces is 5 kilogram. Now, let us assume that the particle was made to move. So the particle is accelerating under these forces. You know, under equilibrium, if an object is not in equilibrium, that object will move. But if the object is in equilibrium, usually it will be stable without moving. Or if it is moving, it will be moving with uniform speed. Are you following, right? But I want us to assume something that, okay, we know the mass of this particle, P, 0.5 kilogram, under this force condition. Assuming that your examiner asks you to find the acceleration of the particle, assuming that mass of P is 5 kilogram, find its acceleration. Find its acceleration. Now I'm going to give you a hint. Do you know the basic formula of force? The basic formula of force. Force is equal to what times what? Of course, we get that from Newton's second law of motion. Okay? Just forget about the concept of Newton's second law of motion. That is what we use in deriving that first formula. But it's a formula most of us know. Okay? In fact, if you've taken lessons on quantities and their units under derived quantities, there is no way someone would not talk about force there. So what is the formula of force? It is a product of two quantities. Use that knowledge to calculate the acceleration of this mass. Remember that the resultant, the total force acting on this mass is 10 Newton. So use that first formula, get the acceleration of the object. Drop your answer in the comment section, in the comment box of this class. This is a live class. Any comment, any answer you drop might disappear at the end of the class. You can come back and type your answer. Okay? Type in the comment section. Let me get to know if you actually still remember or knows how to calculate acceleration when you know mass and force. Thank you for connecting to the class. And remember to subscribe if you are yet to subscribe to this channel of excellence. You know, whenever I mention GMAETS 41, you can imagine the way I stress that 41, because the 41 there is a code of excellence. As you, dear friends, continue to operate with GMAETS 41, you can be sure of one thing: excellence, excellence, and excellence. It is not negotiable. If you're going for an exam after the GMAETS 41's coaching, one thing is sure. Only one thing. You will go in there, sit for that exam, blast the questions that, of course, your examiner cannot dribble you. And you will come out of that examination hall with those A splashes and first class in view. Share these video lessons to your friends, to your departmental WhatsApp group. Encourage your friends to subscribe to this channel. Let's work together. You can support this channel, you know, so that GMAETS 41 will always still have the resources to continue giving you the best. Join the channel on the platinum level or on the diamond level. There you get to support us monthly with, you know, the package that we have there, platinum or diamond. I'll be seeing you tomorrow. You have a wonderful night rest from here.